Okay, good morning. We are going to look at solving some more quadratic equations using the square root property. Um, okay, so the difference here is we're not just solving for an x squared to take the square root of that. We're solving for a quantity squared, so we can take the square root of the whole quantity. So for example, in this problem here, x plus 3 squared equals 4. Um, we have a quantity squared, and to get rid of that exponent, we have to take the square root of that whole side. So let me rewrite this over here. So now to get rid of that exponent to solve for x, we would do the opposite of squaring that side. We would take the square root, which means we square root the other side as well. Okay, so if you take the square root of x plus 3 squared, those are inverse operations, and both the exponent and the radical disappear. But then we would do that to the right side as well, and the square root of 4 is 2. Okay, so x plus 3 squared, the inverse operation of squaring something is taking the square root. So those cancel each other out, and you end up with just x plus 3. And then we do the same thing to the right side and take the square root. That gives us 2. But it also gives us negative 2. So they're actually going to be two separate equations we have to solve for now, because the square root of 4 is not just 2, it's negative 2. So we have to solve both of those equations to get two different solutions. So here we're going to subtract 3 from both sides, and we end up with x equals negative 1. Okay, and then on this side, we subtract 3, and negative 2 minus 3 is negative 5. So the two solutions here would be negative 1 and negative 5. And don't forget, anytime you're solving for a variable, you can plug in those variables to make sure that they, in fact, solve the equation. So if I have x plus 3 squared equals 4, both my answers should fit that equation. So x plus, instead of x plus 3, let's try x plus negative 1 squared. I'm sorry, let me back up a little bit. Wrong. Our x is now replaced. So instead of x, we're doing negative 1. So it would be, instead of x plus 3, it would be negative 1 plus 3 squared equals 4. And that would give us 2 squared equals 4. And that does check out. Okay. And then also plug in the negative 5. So instead of x plus 3, we would do negative 5 plus 3 squared. Does that equal 4 as well? Yes. Negative 2. Okay. So that checks out as well. Okay. All right. So let's take a look at the other equation as well. This is going to be a similar solution. So if you have this down, feel free to fast forward me a little bit. Okay. So x plus 8 squared equals 16. So we want to get rid of the exponent. What's the opposite of squaring it? Taking the square root. Okay, so if we take the square root of the left, we take the square root of the right. That would give us x plus 8 equals 4. Okay, and then also square root of 16 is also negative 4. So I'd have a separate equation, x plus 8 equals negative 4 as well. Okay. So now just to solve for x on both sides, we get x is equal to negative 4. And then on the right side, subtract 8 from both sides, and we end up with x equals negative 12. Okay. And for the sake of time and the video, I'm not going to check my work, but it's always very easy to plug back in those numbers just to make sure you didn't make a little mistake. Okay, moving on. All right, so this one, well, let's go ahead and take a look at it. This is going to be multiple choice. So it's a z plus 3 squared. I'm going to solve this the same way. Okay, so the square root of both sides. That gives us z plus 3 on this side. But what is the square root of negative 14? There is no real number that we can multiply by itself to give us negative 14. Okay, so there is no real solution there. Okay. All right. So that's the basic idea. Now we'll look at just a couple different problems where you get funky answers. So answers that would look a little bit more like this with radicals and just a little bit more funky looking. Okay, so 3k plus 2 squared equals 12. Okay, again, the opposite of squaring something would be taking the square root. So that gives us 3k plus 2 equals the square root of 12. And we'll simplify that in a minute. But it also gives us the negative square root of 12. So we have 3k plus 2 equals negative square root of 12. Okay, so if you recall, to simplify the square root of 12, we want to find out if any perfect squares go in there. So on the right-hand side, I'm going to put my perfect squares. 4, 9, 16, 25, 36, 49, 64. Okay, so do any perfect squares go into 12? Yes, we have a 4 goes in there. So the square root of 12 could be the square root of 4 times 3. And just to keep that going, once we have that perfect square, we can take that out of the radical. Square root of 4 is 2. Okay, so that's what we end up with. Now we're going to get that, still working on isolating our k, so I'm going to subtract 2 from both sides. That goes away, leaves us with 3k here, and then 2 square root 3 minus 2 on the right-hand side, because you cannot take a 2 away from a radical. 3 square root 2 without getting into some messy decimals. Then we're just going to divide by 3. And those 3's cancel out, and we end up with k equals 2 square root 3 minus 2 over 3. And just to kind of peek ahead here, we're going to see if this is going to be in any of our answers up at the top. And that would be this right here. Okay, so let's just check out the other side just to see the other side should give us that then. Okay, so subtract 2 from both sides. It gives us 3k equals negative square root 12 minus 2. And remember, the square root of 12, we simplified to 2 square root 3 over here. So I'm going to skip some of the work on that and leave that as 3k equals negative 2 square root 3 minus 2. Divide by 3. Okay, and that gives us k equals negative 2 square root 3 minus 2 over 3. Okay. And negative 2 square root 3. Okay. Okay, so that actually, I didn't look at that very carefully. So that does not equal that. Okay, but both of these up here are equivalent. They're just the tops are flipped in different directions. Uh, so this answer right here is the same as this answer, and this answer right here is the same as this one down here. So the correct answer would be B, actually, in this particular case. And that's as simplified as we can make them at this point. Okay, let's look at what. Oh, actually, I think that might be an example. Okay, so that's the gist of 2.2.2. And there's a Math Excel assignment that goes along with it and a short quiz. So just let me know if you need help on the assignment, and good luck. We'll see you in class.